Hello children, welcome to today's session. In this session, let us discuss about 7 more questions from the chapter name Mathematical Induction. As we have discussed in the previous video, 2 sums, and in this video also we will discuss two more problems, right? So that 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 and so on n terms. And so on, how many terms? N terms. The thing is, here we need to find nth term. To find nth term, that is our first step. As if you see 1, 3, 5 and so on, they are in AP, right? So here, as the first term is 1, common difference is second term minus first term, 3 minus 1, that implies 2. Okay, let us find nth term. The formula is a plus n minus 1 into d. As a value is 1 plus n minus 1 into d value is 2. 1 plus 2 into n, 2n minus 1 into 2, 2. So that is 2n minus 1. As well as the second terms 3, 5, 7 and so on, they are also in arithmetic progression. So here the first term is 3 and the common difference is 2. Now let us find nth term, a plus n minus 1 into d. So 3 plus 2 into n, 2n minus 1 into 2, 2. So nth term is what? 2n plus 1. Right? Now we found nth term, that is, I can write here our nth term is what, and so on, plus 1 by first one is 2n minus 1 and the second one is 2n plus 1. So this is our nth term. Children, did you understand step 1, how to find nth term? So as 1, 3, 5 are in AP, we found nth term. 3, 5, 7 are in AP, we found nth term. So our nth term is 1 by 2n minus 1 into 2n plus 1. Okay, let me rub this. Now coming to second step, we need to find, let us consider this as S of n. This is our S of n. Okay, which is n equal to 1. As let S of n is true for, let us write, let S of n is true for, S of n is true for n equal to 1. I mean 1 by 1 into 3 plus 1 by 3 into 5 plus and so on plus 1 by 2n minus 1 into 2n plus 1 equal to n by 2n plus 1. Okay, put in place of n 1, that is 1 by 2 into 1 minus 1, 2 into 1 plus 1 equal to 1 by 2 into 1 plus 1. 1 by 2 1 ja 2, 2 minus 1 1, 2 1 ja 2, 2 plus 1 3. Equal to 1 by 2 1 ja 2 plus 1. So 1 by 1 into 3 3 equal to 1 by 2 plus 1 3. I mean LHS equal to RHS. Therefore S of n is true for n equal to what? 1. Is it clear? Second step, children. What is our second step? That S of n is true for n equal to 1. Okay. So let me repeat. Now let us check that S of n is true for n equal to k. That S of n is true for n equal to k. So what will happen is, in place of n what we need to write? 1 by 2k minus 1 into 2k plus 1 equal to k by 2k plus 1. So that is our second step. First we found nth term, and then let us second one. In step 1 we found let s of n is true for n equal to 1. In second step, let s of n is true for n equal to k. Now what is our third step? Let s of n is true for n equal to k plus 1. N equal to k plus 1. I mean in the place of k, we need to substitute k plus 1. See children, let me do it here. 1 by 2 into k plus 1 minus 1 into 2 into k plus 1 plus 1. 1 by 2k plus 2 minus 1 into 2k plus 2 1 are 2 plus 1. 1 by 2k, 2 minus 1 1, 2k, 2 plus 1 3. Okay, when you substitute n equal to k plus 1, what we are getting? 1 by 2k plus 1 into 2k plus 3. That we need to add on both LHS and as well as this should be added here. See, 1 by 1 into 3, 1 into 3 into 5 plus 1 by 2k minus 1 into 2k plus 1 plus we need to add this now. 1 by 2k plus 1 into 2k plus 3 equal to k by 2k plus 1 plus 1 by 2k plus 1 into 2k plus 3. Okay, let us solve now RHS. What is our RHS, children? This is our RHS. K by 2k plus 1 plus 1 by 2k plus 1 into 2k plus 3. Right? Now what is the LCM, children? As LCM is 2k plus 1 into 2k plus 3. Already we have 2k plus 1 is here. Now the term is 2k plus 3, we need to multiply to k. K into 2k plus 3 plus 1. It will become 2k square plus 3k plus 1 by 2k plus 1 into 2k plus 3. Factorization, 2k square, 3k we can write as 2k plus 1k plus 1 by 2k plus 1 into 2k plus 3. If I take 2k as common, I will get k plus 1. If I take 1 as common, I will get k plus 1 by 2k plus 1 into 2k plus 3. Now if I take k plus 1 as common, I will get 2k plus 1 by 2k plus 1 into 2k plus 3. 2k plus 1, 2k plus 1 cancel. So what we got, children? We got k plus 1 by 2k plus 3. K plus 1 by 2k plus 3. How can I write this? See, children, this is our term. In place of k we got k plus 1 by 2 into k I can write as k plus 1 plus 1. See, 2 into k, 2k, 2 1 are 2 plus 1, again we get 3. See, now we got both LHS and RHS are equal. Yes or no? We are checking let S of n is true for n equal to k plus 1 or not. So we have taken RHS, again we got LHS only. Therefore, LHS equal to RHS. S of n is true for n equal to k plus 1 by principle of mathematical induction. S of n is true for n belongs to n. For all n belongs to n. So this is the method of solving any problem by using mathematical induction. Now coming to second problem, so that 1 by 1 into 4 plus 1 by 4 into 7 plus 1 by 7 into 10 plus and so on, n terms, that is equal to n by 3n plus 1. Okay. So the thing is, first we need to find the nth term. If you observe the terms 1, 4, 7 and so on are in AP, and the second one also 4, 7, 10 and so on are in AP. In both the cases we need to find nth term, as nth term formula is A plus n minus 1 into D. As here A value 1 plus n minus 1 into D value is second term minus first term, 4 minus 1, that implies 3. 1 plus 3 into n, 3n minus 1 into 3, 3. 3n minus 2. Right? Now in this case let us find nth term. A value 4 plus n minus 1 into D value is second term minus first term, 7 minus 4, 3. 4 plus 3n minus 1 3 is 3. So 3n, 4 minus 3, 1. So what is our nth term, students? Our nth term is, here let me write our nth term, plus 1 by, we got 3n minus 2 and 3n plus 1. Okay, that is our first term, first step, that we have found our nth term. Now what we have to do? Let us consider S of n as this given question we get to consider as S of n. This is our S of n. So step 1 is that S of n is true for S of n is true for n equal to 1. That S of n is true for n equal to 1. So what is our LHS? 1 by 3 into 1 minus 2, 3 into 1 plus 1 equal to 1 by 3 into 1 plus 1. 1 by 3 1 is 3 minus 2 1, 3 1 is 3 plus 1 4. 1 by 3 1 is 3 plus 1 4. So 1 by 4 equal to 1 by 4. Both LHS and RHS are equal. LHS equal to RHS. Therefore S of n is true for n equal to 1. This is our first step. Now coming to second step. Is it clear, children? Now coming to second step, let S of n is true for n equal to k. I mean 1 by 3k minus 2 to 3k plus 1 equal to k by 3k plus 1. That is our second step. Now what is our third step? That S of n is true for n equal to k plus 1. That S of n is true for n equal to k plus 1. Children, listen carefully. Here left hand side 1 by 3 into, in place of k we need to write k plus 1 minus 2 into 3, in place of k we need to write k plus 1 plus 1. Okay, now 1 by 3k plus 3 1 is 3 minus 2, 3 into k 3k plus 3 1 is 3 plus 1. 1 by 3k, 3 minus 2 1, 3k, 3 plus 1 4. Okay, when we substitute in the place of n, in the place of k plus 1, we got 1 by 3k plus 1 into 3k plus 4. That we need to add on both LHS as well as on RHS. Whatever we got this term we have to add now. Okay, let me add. That is 1 by 1 into 4, 1 by 4 into 7, 7 into 10 plus 1 by 3k minus 1 into 3k plus 1 plus this we have to add here now. 1 by 3k plus 1 into 3k plus 4 equal to C. Here this is k by 3k plus 1 k by 3k plus 1 plus 1 by 3k plus 1 into 3k plus 4. Okay children, now what we need to do? We need to solve RHS. What we have RHS? This is our RHS. Let us take RHS now. K by 3k plus 1 1 by 3k plus 1 into 3k plus 4. So what is the LCM children? As LCM is 3k plus 1 into 3k plus 4. So I mean k into 3k plus 4 plus 1. Right? K into 3k, 3k square, k into 4, 4k plus 1 by 3k plus 1 into 3k plus 4. Factorization, 3k square plus 3k plus 1k plus 1 by 3k plus 1 into 3k plus 4. If I take 3k as common, I will get k plus 1. If I take 1 as common, I will get k plus 1 by 3k plus 1 into 3k plus 4. Now again if I take k plus 1 as common, I will get 3k plus 1 by 3k plus 1 into 3k plus 4. 3k plus 1, 3k plus 1 cancel. So students, what we got? We got k plus 1 by 3k plus 4. Right? So see here, what is our LHS? N by the k by 3k plus 1, right? So in place of k, we got k plus 1. This 3k plus 4, I can write as 3 bracket open k plus 1 plus 1. See, 3k plus 3 plus 1, again you get 3k plus 4 only. See, we got k plus k plus 1, 3 as it is, k plus k plus 1 plus 1. So we got LHS. Therefore, LHS equal to RHS. So S of n is true for n equal to k plus 1 by principle of mathematical induction. S of n is true for all n belongs to n. Student, did you understand how to do the problems from mathematical induction? I hope I explained the concept very clearly, children. Okay, thank you.